Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel and I hope you all are well. Today in this video, we are going to learn about synthesis of caffeine. You know, this is very important and interesting compound. You all know the importance of caffeine. Here is a single bond. I am interrupting. So this is the structure of caffeine and we want to synthesize in the laboratory. We also know from natural sources we are extracting. So in this video I will talk about the procedures how to extract this compound from tea leaves. So take or place 15 gram of tea leaves. How much? 15 gram of tea leaves, 5 gram of calcium carbonate powder and 200 milliliter of water into a 600 milliliter beaker. Boil the solution on hot water or hot plate for 20 minutes. How much? 20 minutes. With occasional stirring. Occasional, not continuous. Occasional stirring. You know the stirring process. Then what you need to do? You need to cool the solution, but while it is still warm, vacuum filter through a Buchner funnel using a fast filter paper if available. If it is not available, you have no option. Then normally hot solution are not vacuum filter. Rinse the leaves with 50 milliliter of water carefully. Press out as much filtrate as possible. Since the caffeine is in the aqueous layer, rinse again with 50 milliliter of water. Then cool the solution to room temperature and pour it into a 500 milliliter separating funnel. 500 separating funnel. You know the separating funnel. Extract with 35 milliliter of methylene chloride. In a departure from the normal procedure, it will be necessary to vigorously shake the separatory funnel in order to extract the caffeine. First, relieve the pressure. Build up as soon as you mix the two liquids. Then shake vigorously for 10 seconds and relieve pressure and repeat the shaking 2 more times. An emulsion will probably form. Then what you need to do? To break the emulsion formed in the methylene chloride layer, slowly drain the methylene chloride layer through a small amount of anhydrous magnesium sulfate in a powder funnel with a loose cotton plug. So tight plug will prevent the drainage. Then extract the aqueous solution once again with 35 milliliter of methylene chloride, repeating the steps above to collect the lower layer. Combine the methylene chloride extract and if necessary dry further with additional anhydrous magnesium sulfate. Then methylene chloride solution will be steeped on a roto evaporator. Tear away a 100 milliliter round bottom flask and transfer the dried methylene chloride solution to it. But be certain that there is no magnesium sulfate in the solution. Stripping this solution to dryness will take less than 5 minutes. You will be left with a small amount of residue with a greenish tint, often the way of crude caffeine by difference. Then add 5 to 8 milliliter of hot acetone to dissolve the crude caffeine and transfer the solution to a 50 milliliter aluminum flask for recrystallization. Add a few drops of petroleum ether until you reach the cloud point. Caffeine is less soluble in this mixed solvent and is just beginning to precipitate. And then cool the solution. If you do not get a precipitate, you may have used too much acetone. Carefully boil off the excess on a steam bath using boiling stick for ebullitions. My friends, suctions filter and caffeine using a small Hirschfeld funnel and proteolymither as a transfer rinse solvent. A second crop of caffeine may form in the filtrate as the solvent evaporates. And this second crop can also be collected by vacuum filtration, but keep it separate from the first crop. After air drying, weigh each crop and record your percentage caffeine recovered from tea. So, my friends, the summation will be performed as described and how you carefully perform. So, you use 50 milligrams of your caffeine to make the salicylate derivatives. But if you have this, then you will use 50 milligram of your caffeine to make a salicylate derivative and sublime the remainder. So you will not take melting point of purified caffeine, which would require a sealed capillary to prevent sublimation near the melting point, and then save the purified caffeine in a sealed vial. You will use some of this material for TLC analysis next week. So, my friend, caffeine is a base which can react the acid to form salt. A well-characterized salt of caffeine is caffeine salicylate formed by using salicylic acid, and this derivative of caffeine has an accurate melting point. Later this time, I will show you to what is the main preparation of derivative. So, if you want to make the derivative of this compounds, means caffeine salicylate, using analytical balance, there are several top loader balances in the lab. Weigh 50 milligram of caffeine and 37 milligram of salicylic acid. Both can be plus or minus 1 to 2 milligram, and dissolve them in 4 milliliter of toluene in a small 25 milliliter aluminum flask by warming on a steam bath. Add 1 milliliter dropwise of petroleum ether and allow the mixture to cool and crystallize. If necessary, cool it and ice water bath. Collect the crystal by vacuum filtration, air dry, weigh, record the yield, and take melting point. This melting point literature value 137 degrees Celsius. So, my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.